All right, so we're going to have a little exercise here about how we're going to map to CDEs. So just going back to this kind of thought experiment we had earlier, we've been talking about how we want to include, as many sort of important variables as we can. Going back to this data set, which really is, this is why Gene gave this as an example, because this really looks like a pretty typical type of data set. And what we're trying to get across here is there's just some small formatting changes that we would do to this that are going to help us work into the future using CDEs, using this tidy format that we've been talking about, and ultimately making sure that our data is sort of compatible with other folks. So typically what we'll do, we've talked a lot about CDEs, so we're going to get in a little bit and kind of look at some of these precise CDEs now. And typically what we'll do, the way things are at least arranged on the PRECISE website, is we'll sort of arrange these variables that we're interested in into different domains. So we talked earlier, right? We had some great examples. Folks said we need things like what the species is in our experimental group. So those are things that would typically fall under the domain of something that we would call subject-specific metadata, and give us a sense of who these animals are and where they come from and what their age is and all of that. We'll typically also want to include some kind of injury parameters, what the injury model is, what are the specifics of how that model works, and then of course things like our outcome measures, right? The actual dependent variables that we're measuring and testing statistically. So just to give you kind of an overview of how we would typically map our data to CDEs, we would have, if we kept it within these three domains that I mentioned, our independent variables, the subject-specific metadata, and our injury CDEs, for instance, if we're doing, say, a closed head injury, and our dependent variable being our Barnes maze, we can go into each one of these sections, and we'll do this in just a moment. We'll use the actual Barnes maze as an example. We can go into these domains and pull down the relevant CDEs that we need for those. What that looks like then is we will pull those down, and we'll get the actual variable names that we can now put across the top of our new beautiful CDE mapped spreadsheet, and then we can fill our data in from there. So where do we actually get these CDEs? Well, we get them from the data dictionary, okay? So basically, we're going to go in and look at it in just a moment, but it kind of looks something similar to this. You would have what a data dictionary actually looks like is it will have the variable name, it will have the CDE name, which is sometimes slightly different, something that's a little bit easier for machine readability. And then we'll get a lot of information, sort of metadata about that variable itself. Things like what's the minimum value that you would expect, or the maximum value? What's the actual unit of measure that you're using here? We'll typically have a nice, concise description of what this variable actually is. So this is sort of the importance of data dictionaries altogether, because it really gives you that context that you need, even when you look at a data set and go, okay, I know what this variable is, but this gives us everything else we would need to know about it. And so what we can do is we actually grab these variables out of the data dictionaries, and then we can put them into a new spreadsheet. So we'll walk through this here in just a second. So these are some of the data domains. And so what we're going to do, what I'd like to sort of our objectives for this exercise here is I want folks to be able to go onto the PRECISE website and access a data dictionary. I'll show you how to do that here in just a second. We'll pull down a data dictionary. We're going to copy the variable names that we're interested in, and then we're going to put them into a new spreadsheet that will allow us to sort of reformat this into a way that's going to be useful for others. So this is, Jane was nice enough to offer up the data that we're looking at here today. So this is actually, so kind of to give a little background on the experimental design here. This is a deep brain stimulation study, basically looking to see whether the stimulation improves spatial learning after a lateral fluid percussion injury in the adult male rat. That's great. That gave us a lot of information there. And so overall, just the experimental design here after the TBI itself, what we had was Barnes maze data after injury on days 8, 9, 10, and 11. Okay, and so sort of the idea here was to see whether or not after stimulation there was an improvement in their spatial learning. If we're not familiar with Barnes-Maze data, just in general, this is kind of how it's laid out. You can put a rat up on this sort of elevated table. They don't like being out in the open and bright lights and things, so they're motivated to try to escape, and they will search around and find an escape spot. And one of the main outcomes that we measure there is the latency to find that escape spot. So if you remember earlier, we saw there was a data sheet that had latency written on it. So that was basically it. So one of the things, by the way, when we're talking about these outcome measures, one of the things that are very useful in things like CDEs is we can put down all of the kind of metadata about the actual apparatus. So we'll see in just a minute when we look at that data dictionary, there's the ability to write down, what was the diameter of the table or the height of it and how many holes and all of these things. So again, these are going to be the two spreadsheets we want. Hopefully everybody's able to get in there. You've been able to find these. And so one you've seen already. That basically looks like this, right? And so we have this spreadsheet that has latency up here. We have our animal name. We have what groups they're in and their treatment. And then we have these 8 trials. And so this was basically our latency to find that escape hole. And so
Anita has a question.
Yeah, I'm sorry.
Hold on, please. Would you like to? How do you get to this? She says, it's a good thing I'm on my way.
I'm not seeing like where that thing is.
Hold on just a sec.
It's the CDE mapping.
CD mapping.
Is that right? Barnes-Maze? There we go.
Yes, sir.
Does anybody else need help?
Yeah. Show.
If anyone else is having trouble, you can raise your hand and I will come and find you.
Hold on. Yeah. Look, I learned how to do this. Push right to the left. There we go. So cool. Gotta drift it over. It's a big reveal. Okay. Oh shoot! But now I got to do it on there. Hold on. Okay. So this is that little bit.ly. Oh gosh, this looks awful. And if you scroll down here, there is a. Yeah. Sorry. This says CDE mapping Barnes-Maze latency and CDE mapping Maze. These two little green spreadsheet guys. Good. Okay. Get you to go away now. Okay. So the third piece that we need for this puzzle in order to basically map the data that we have to a new CDE spreadsheet is to actually go and get the data dictionary that we need. So the way to get that is to go to PRECISE-TBI.org.
We shouldn't just write these on a napkin, is that right?
Correct. When you go to precise-tbi.org, you will go to the resources at the top, and there is a little pull-down menu that shows you common data elements.
Paper towels last longer than
That's
Thank you, Yes, perfect.
that is improved data management. That's right.
Talk to Stuart about it, please.
Is everyone able to get to the to this CDE common data elements page? Perfect. Okay, great. And what you'll see on that page, you have 2 buttons. You have a metadata CDEs. So we talked about this, the metadata being those subject specific metadata. But what we're interested in, we're going to click on this other one that says sets of CDEs, because that's where we're going to find our outcome measures. And all we're interested in today is just showing you how we can map some of this Barnes-Maze data into a tidy format that uses our CDEs. So if everyone can click sets of CDEs, you should get to this page.
Yes.
Yes.
Do
All right.
Yeah,
Good. I don't see anyone shaking their fist. Okay, good. And what you'll see here is, by the way, this is, for everyone who has not been here to this site before, these are the very hard work done and ever evolving current sets of precise CDEs. You'll see they're organized here by, these are just outcome measures here, but we have some of them are outcome measures as well as the injury models. We have the Barnes Maze, beam walk, CCI, closed head impact. You can read all this. These are, a ton of really, really useful CDEs for any of the work that you're doing. If it falls under one of these categories, you can go here and pull down the data dictionary for these CDEs. So all we're going to do today, though, is just Barnes Maze. So it's the very first top left there. You can click on Barnes Maze. You can click either CSV or Excel version. Either one is fine for what we're doing today. And so you'll want to download that as well. So now we've got three spreadsheets going. Okay, this is the wrangling part. Is everyone able to access the Barnes Maze CDEs? Yeah, good, great. Okay, and it should look a little bit like this. My top row here has are large and bold, so it's easier to show you up here, but it should look very similar to this. So we are, if you open this up, what you're looking at now is the actual CDE data dictionary. And like I said, this sort of hopefully will make this a little bit more real and practical for you. There's a few ways that they're organized. First of all, they're organized into different categories. Some, because we're looking at Barnes Maze here, some are these sort of equipment kind of metadata, right? Tell you a little bit more about what the equipment is like. There's the procedural parameters, there's the actual data that's collected. And we also see that they're organized also by CDE level, right? As Neil and Michelle mentioned, there are ones that are sort of core to it, some that are supplemental, some that are recommended. We have the variable name, right? So this is the actual name of the variable that's going to go into your new spreadsheet. There's also a title that kind of gives you a little bit more description, and then the actual description itself that is a longer kind of worked out phrases that explain exactly, hopefully in terms that are understandable to anyone who's interested in this, kind of what exactly is being captured here. Okay, and you probably can scroll over and see there are even more. I didn't want to make it too small on the slide deck here, but you can see there's different, what types of allowable data. Is this numeric data? Is this alphanumeric? Is this free text, right? Okay, is everyone able to, we're all on board looking at this data dictionary? Okay, great, thank you. I appreciate the nods because yeah.
So equipment are green, procedurals are pink, and data collected are blue.
Unless they're CSV, and then they're not.
Okay,
You have CSV,
I do, yeah, okay. Yeah. Yeah. Most of us who work in CSV see things in black and white. Abel can attest to that. Yeah, right. So all we're going to do today, all I want to do is we're going to grab two variable names. We're going to do them one at a time. We'll walk through this. I want you to find in the variable name column, I want you to find the variable that's named BM trial num. Sorry, BMT trial num. Got it. Okay, you win. All right, you get a cake. So this is going to be for our trial numbers. It doesn't have to be a race. Some people are just competitive about everything they do. That's true. Yes, that's right. So all we want to do is find that variable name and we're going to copy it. You can, however you like to copy things, we're going to copy that and we're going to move it over the thing that we've copied, that variable name, BMT trial num. We're going to copy that over to this other spreadsheet, the third sheet in our little series here. This is the one that just the other one that you downloaded. This is the one that just has we got this started for you. All it is showing is two of the animals in Gene's spreadsheet. We have an animal ID column and we have an injury elapsed column. Okay. Okay. that one's,
ID time.
yes, that's right. It's the one that says ID time only.
ID underscore and underscore time underscore only, correct?
You have underscored it correctly. That's right. So we've copied that variable name. And we're going to go over to the very first row in column C of that, of the one that we're looking at up here, and we're going to paste it. Boom. Okay. Right. Then we're going to go back. We're going to go back to our data dictionary here, and we're going to grab one more variable name. And this other variable name is kind of long, but it's BMT latency escape hole finder. We're going to copy that one also, and then we're going to go back again. This is part of the wrangling part. Yeah. BMT latency escape hole finder. You'll see that it looks very similar to the one below it, but you'll see the difference is that one is the one we're highlighting is a core CDE level, while the other one is just supplemental. Yeah, I was afraid because I don't know if the Excel one might be in a different order. But if that's how your brain works, it's row 26. We're going to copy and paste that one too. So what we should have right now, in our as we're starting to fill this out here, we should have now four columns. We have our animal ID and our injury elapsed time, and now we've got these two new variable names that we've added to the top of this. Yeah.
I was just listening to the chatter over here, and people were saying, man, I need multiple screens. And if you ever walk into an informatics lab, you will see that they have multiple screens. Everyone in our team has like 4.
Yeah.
No, there's never BA issue computer for anything.
You could have finished that sentence sooner. I never used my VA computer for, and that's not true. I check my mail every now and then. Okay. Okay, so are we here? Is everybody here with our new? These are our CDEs. We are doing it. We're currently CDE mapping. We're like halfway through. Okay. All right. Okay, good. All right. Here, so now that we're done with so for right now, just for this simple example, we're done with our CDE dictionary. We can put that away. We can minimize it. We can close it. Put in the don't throw it in the trash, because now it's good to have it. But we're going to put that one aside. So all we want to be working with now is our new. You'll see that we have these cells that are just waiting for data. Uh-oh. Sorry. Yeah.
Perhaps it's good that people always check what that BMT trial number means and not just assume.
Yes, absolutely. Don't just assume that you know that. That's a great point, Marianne. Well, sorry. What she said is you should always check, look at the description and the title in your actual CDE dictionary, data dictionary, to confirm that this is the actual variable that you want, the one that you mean to be using. So just to explain what these are, the BMT trial num is the trial number. Yeah.
It's going to be denoted as BMT files for each one of your study measures that you're.
If it is Barnes Maze task, BMT. That's correct.
Yeah, the way the nomenclature for these just have BMT at the beginning to denote that it's a Barnes maze trial.
Sorry.
Oh, sorry. Okay. So what we're doing here is we're putting.
Hold on one sec, Adam.
Audrey?
Oh.
What if you're creating completely new CDEs because you don't do behavioral studies? I might be jumping the gun, maybe like half a day or so.
if you were creating new CDEs, I would recommend talking to the people that make CDEs and get them vetted and validated and yeah, sorry, go ahead. About
Oh, yeah. So, and I'm assuming you know the answer to this, but a common data element by definition means that it has been agreed to by the community and is common across. So the data elements you create are not common data elements. They are data elements. Yes.
And I'll add also that if say you were doing Barnes maze and you have a data element that's not common, it's still critical that you save that data. So you can create a unique column, right, with your unique data, but then you have to go to the data dictionary, right? Because it's not going to be in the downloadable data dictionary. You have to add any of your new terms, any of your new elements into the data dictionary so that anybody that's looking at your data can figure out what those columns mean. But you should definitely refer to how we make the CDEs so that you put the correct information in there so somebody can replicate.
right. And when he's talking about data dictionary, this is your study specific data dictionary that's going to just include these particular variables that you've grabbed. So go ahead, Michelle. Oh, go ahead, Adam.
So what she just said is, oh, I didn't mean CDE, I meant data dictionary, I think. And so I think you guys answered this question. If you are collecting a variable, having a data dictionary that's in this format for that new variable, if you've invented something new, that's the first step.
So let me just clarify that a little bit or add to that a little bit. So if you have studies, let's just say not behavior, and most of them you see on there are behavior, right? So what we need to do better, this is very good feedback, we need to tell people what's coming, right? Because so for example, like biomarkers are coming soon. Histopathology is going to be next. We have imaging. So we do want to hear from the community which ones that you want, because we can either, kind of put it on the list or invite you to be the chair of the working committee.
mRNA and protein levels also.
Yes.
Not just, I mean, we can go very deep into whether it's spatial transcriptomics, but at the simplest level, like PCR data, Western blot data, that kind of stuff, I think is important.
It's coming. So we don't have it. And we're also trying to harmonize with other fields that have some of those. So for example, in post-traumatic epilepsy, they have a lot of omics CDEs. So we're in the process of, well, I shouldn't say that, epilepsy does. So the PTE effort is taking TBI and epilepsy and harmonizing it. So there's still, and I think I just wanted to preface some of this where it's going to be easy for you first adopters. I assume that's why you're here, right? To get frustrated because we will be updating these. So it is an evolving process, but we do want to hear from you. And so it's not the end of the world. Like if you use that, say you're doing Barnes Maze and you use all these, or some of these data elements, and then you want to go share your data, and then all of a sudden you go back to PRECISE and you say, oh my gosh, they updated them. Now there's new ones. You have to go back to the beginning. No, you don't. You just are going to cite which version you used, right? So it's because nothing, it's going to be fine. But and you're going to be looking for stuff you're not going to be able to find. If you want to make your own, though, we will leave, instructions on how to do that, and you're welcome to to ask us about it. And the idea is that, like, so Marianne's point was that it's not common if you can't find it and you're making it, but there's got to be a first step, right? Like maybe you're not the only one. And the more that it's out there, the more we're going to know that it's common. So it'll be like an exploratory CDE initially. And then if people start using it, then we'll elevate it to whichever category. Now you're all done with your mapping, right?
And one of the other things that Michelle just talked about is that these are living. And so 5 years from now, it might not be called BMT latency because we've harmonized with somebody else, right? But if we all put in the effort now and we have a common name, common column, it's really easy for machine learning to go in and figure that out for you so that you don't have to go back and do it again, right? We all think that, oh, latency is easy. Everybody's just going to use the word latency, but some person might use time, some person might use seconds. And when you get to some of the other details, it just creates a lot of variance in the column names. So by constraining it, it makes it just much easier for machine learning to figure it out. And then in the future, if we need to change it, it'll be very easy. So it sounds complicated, but honestly, it's not. Any more questions before Russell? Go ahead, Russell.
Okay. So we're all here, right? We've got these four variable names across the top, right? By the way, we're working towards something tidy. What you see so far is that we're about to fill in. Can't I see where's my arrow? Oh well. Oh, you can see it. I just can't see it. We're going to fill these data in here in just a moment, and what we're going to have is a nice sort of square spreadsheet that doesn't have any rows that are blank for no reason. We don't have any columns that are blank for no reason. We're going to have a nice tidy format. So what we can do, so let's go back to this Gene's data set here, right? Okay, so what we have is that there are 8 trials. But we know from his experimental design, we didn't know this before, right? We can't tell from his experimental design when these trials were done. But I gave you a little background information that he was testing these animals on days 8, 9, 10, and 11. So there are 4 days after injury where they had trials, and they had 2 trials on each of those days. And so when you look, sorry, let me go back here. When you look at this, what I've added here for you is that injury elapsed time this is just for 2, you notice this is just for 2 of the subjects, just as an example here. We have, oh, there it is. Oh, now it's on my screen, but not on that screen. Oh, that's silly. Oh, no. We have, I'm not going to point anymore. I'm just going to talk. We have for each of these animals, you see that the animal ID is repeated a number of times. It's repeated because time is now going down. So we have, oh, this looks good. Does that work? So we have day 8, 8, 9, 9, 10, 10, 11, 11. Oh, cool. Okay. Now I put that in there because what that's showing, and if we went back and looked at our data dictionary, we would have injury elapsed time days after injury. So for these animals, we have 2 time points for each day. And what we're going to add in then is you can go actually, if you'd like to do it now, you can go into BMT trial num, this column C here, and you can just write 1, 2, 1, 2, 1, 2, 1, 2, or you can write 1, 2 once and then copy it down. What that's going to show is that we have the trial number for day 8 and the trial number, the first trial for day 8 and the second trial for day 8. And you have the same thing for day 9 and day 10 and day 11. And that's all for the same animal, right? And then we move on to the next animal. This is a little bit of reformatting from the way it was here, which is what we would call a wide view, because we have time going across. It's going across trials here in the way that Gene originally had it set up and the way that a lot of people often set up their work. What you may realize, though, is when we're trying to get this into a format that could be readable and common across different labs, since we want our variable names to be at the top of our list here, we don't want new separate variable names for each time point, right? We don't want BMT latency escape hole finder 1 and BMT latency escape hole finder 2, right? You see, the problem would be when in that wide format, you would have to be creating a new common data element for every time point. The reason we like it this way, this makes it much more machine readable, is to turn it in what we call a long view, which is then allows you to only have a single column that refers to the value. But then what we have it going down in rows, that's where time is repeated. So you have a single column for time, which is injury elapsed time. We have another column, trial number, which gives us more information about what was going on in that particular time. And then we have a third column that's actually the value that's of interest. Does that make sense?
So I think I know where this is going. If you had 10 different studies and you multiplex all this together, Is there an easy way to get the distribution of these times out of that so that you can look at that as a variable across multiple studies?
Yeah, as long as you're using a time variable that's consistent across those studies, and you know what that time variable represents, then that makes it much easier, because then you can basically just align. It may be instance, let's say, for instance, there's some other probe trial that you do in a different type of outcome measure that's only on day 10. Well, then that would be its own column, and you would see a lot of missingness because you don't do that on day 8 or 9 or 11, but you'll have it on day 10. And that is great for us. This is another thing that a lot of people get a little bit shy about, like, well, I don't want to set it up in a format where there's going to be missing data. The machines, and by machines I mean a Bell, they love missing data because that's informative, right? That lets them know, well, there was nothing collected on those days.
First question. I'm sorry, I can run. So, okay, so this is the positive case. Can you also track what you wind up rejecting because it doesn't fit into your data set?
Give me an example?
So let's say, you had things that didn't fit into your format, or it was missing data, but you wanted to confirm it for one reason or another. I mean, I see these CDEs as a filter, but do you know what you've filtered out is the question.
Ideally for us, we're not interested in filtering anything out.
I know.
Yeah.
which is why I want to know what, you wanted to filter, because the CDEs by definition are going to tell you this is explicitly what your information is, right?
Right. So that's assuming that you would only be working within CDEs, like
Right.
Right. And so you very well could have many more, and this is sort of to the point over here. You may have many more other UDEs, unique data elements,
Right.
that are just for you. They can play perfectly well together. That's
Right.
okay to have a spreadsheet with both in there.
Yeah.
The CDEs are not completely prescriptive, saying you can only. We wouldn't want that at all. And in fact, so the more people start to use, folks may only use 1 or 2 of these CDs. We may come to consensus that a very minimal 3 or 4, animal ID, sex, species, using those CDEs to start with would be great, because even that would make things so much easier in the world. So
yeah, it's just really a question of what you're truncating out, and that's what I'm trying to ask about. But look, this is a great success because I was able to track this without even doing it on the computer. I know what you're doing.
Yeah,
So-
and just to be clear, this is purposefully sort of simplified so that we're only just doing 2 of these at once. But there is we wouldn't need to be truncating anything. We would be able to include as much of this as possible. And in fact, what actually ends up happening is you often end up, like, let's say, for instance, if I added one more CDE here that was the Barnes-Maze diameter of the table, right? You would have column E that was diameter of the table, and that would be copied the exact same all the way down, right? So you do end up with a lot of stuff that seems sort of redundant, but that just works much better in this format that way. So you get, and I'll show actually example of kind of a finished mapped to CDEs. You get a lot of what seems redundant, but the reason it's not redundant is because each one of these rows then has so much information for that particular animal. Row number 8 will tell me this is STBI2 animal, but that was on day 11 of that animal, and it used this Barnes maze that was, it can give all of this information in that sort of dimension too. So thoughts, comments?
Is this what you're doing now? Does that require the investigator, the tech, to enter it by hand, or have you created macros for the major image capture, motion capture, to then use this, put into this format from?
So there's definitely, so we don't have to do things by hand. There's definitely different levels of automation. So one, I'll show you here in a second. We're going to take a whole big long row and we're going to transpose it. But beyond that, we often, many of us work within Python or R, or these scripts that, these languages that sort of allow you to do this sort of quickly and kind of naturally. I'm doing it this way, so like illustration purposes, but there's pretty easy ways that you can actually flip this format pretty quickly that will sort of automate it for you.
Okay. So the keying error is,
No, exactly. And that's exactly why we typically wouldn't do it this way. And actually, I think tomorrow Abel's going to have some interesting sort of R coding, but definitely like for us, I would typically not do it this way. I would do this in a coding language so that you will be able to start from where we started, end up where we got, and see every one of the steps along the way so that there's no concern that you've somehow, yeah. Right, exactly.
Sorry, so I'm looking at like the CDE level and I'm looking at like what's core and what's supplemental. Is there a way in the future we could vie for something that's maybe supplemental to be moved up a level into like the core level?
Yeah, you just gotta, you have to find Michelle after this at the bar. Just
Okay.
tell her, make your case. No,
Okay, okay.
Go ahead. Go ahead.
Thank you.
No, I kidding aside, but I'll let Michelle answer that.
So I think it's, I mean, like I said before, it's the community is supposed to help. We purposely though trying to keep core at a minimum. Because so it doesn't really matter what we call it in Precise for you to use it.
So something that I'm thinking is more supplemental to our core, then that we would reclassify in our mind as we're putting it up.
Sure.
Can I answer that one? All right. I'm a curator. I've been a curator for a long time. And one of the things that we ask is we ask people to fill out forms. And if they have to fill out 4 variables, 4 things, they can usually do that. If you ask them to fill out 5 things, I think you're good to go. But anytime you get over about 5 things, you end up getting 4 things. So, and those start to be really inconsistent. So Michelle is right. The way that you actually get more data is to ask for less and get the people who want to fill in the stuff actually to do then more of that as they want to. But making things required, like we have to be really, 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 really careful with that, because we will get less and less and less out of people just seeing what the psychology of this is.
Hi, I'm Javier, postdoc at Hopkins. So the way that I see CDEs and all this, it's not something you're required to use. It's a tool that you should use to standardize the way that you're reporting your data. So it doesn't mean that if it's not in the CDE, you cannot use it. It doesn't mean that you have to use every CDE they give you. So they just give you the option of using those to label your different variables so that whenever people use your data set, they can compare that to their own. And so the important thing is your own data dictionary. In that, you're actually going to define what every single one of your own variables mean and how you're reporting it. And so once you paste that with your raw data, people can actually look and see the way that you're reporting it and how they can use it.
Okay. Remember this? Gene's cool data.
So Anthony, getting back to perhaps your original question, what if I did Barnes Maze 8, 9, 10, 11 for 3 years in a row and then changed it and did like 11 through 14 the next few years? Tidy format is so much better at managing that, this long format, because otherwise how do I assemble all of those rows? With Tidy, if you look here, when I get down to whatever animal ID it is, the injury elapsed time data changes. Right. And so I can put in 10, 11, 12 or 15, 16, 17, and it all fits in that same format. And then you can go with an R or a Python and you can actually do analyses. You can compare what's the difference if I do 8 through 11 versus 10 through whatever. And then you can also, if it turns out there's no difference, very easily just combine them. But you can't do that in a traditional long format where every single study has its own Excel file. That's impossible. But by doing it this way, even if I keep them in separate tabs, and PJ will talk about this later, they're all in the same format, and it makes it very easy for me to answer those questions that you posed in that initial question. Does that make sense? Mine I'll say ND, they're letters.
It's alphanumeric. So yeah, going back to the original way this data set was structured, remember we had it in sort of this wide format. So if folks are interested, like I said, many of us would typically do this in sort of a coding language that would allow us to kind of flip this between kind of wide and long format relatively easily. But I just wanted to, for illustration purposes, if folks are playing along here, if you want to just grab, so this is this one particular animal, STBI2 here in row number 3. If you were to just drag your cursor along and highlight the actual values that are underneath trial 1 through 8 there, if you highlighted all of those, you could go and click copy. And then you could go over to that particular CDE, our new long view CDE latency CDE. You can go to the top of that that first cell there, and you, instead of saying paste, we can hit this paste special. I don't know to what extent people are familiar with this option, but it can be very useful if you're working within Excel. You can go to paste special instead of regular paste, and this paste is special, because it gives you a bunch of other options, including one. There's a little box that you can click down here called transpose, and all that does, if folks are trying it out, all it does is take whatever you've copied along. I don't know if I can point them. Oh yeah, there it goes. Yeah, this little transpose box. We click on that, and then we hit OK. And what will happen then is all that stuff that was wide is now long, and it goes down right along there. So I've actually just I've done this for both of these subjects. So if you do it first for the first subject, it will only go down to row 9 here. But then if you go back and then copy for the second row, and then paste special down here, it will go right underneath. If folks have more questions about that, let me know. But hopefully what we can kind of get a sense of here is what we've done and how and why. I think we've sort of talked a little bit about the why we've done it this way. But basically now what we've got is what used to be in this sort of wide format where we had these 8 trials, but we didn't really know a whole lot about it. We now have variable names at the top that would be consistent across anyone who's doing, if anyone is doing Barnes Maze work that are using these CDEs and formatting it in the sort of proper, tidy way, then anyone else doing this work would be able to look at this and merge with other people's work, and if nothing else, be able to understand exactly when these values were collected and what these values mean, because the underlying, we have this variable name, but again, the underlying data dictionary tells you a lot more information about it. And so now we end up with a very simple, it's still a very simple spreadsheet here, but it has much more information, and it will play well with others. Here's just an example, though, of course, this is how things might look if you were to say include many more of those Barnes. I know this is very tiny, but what we included here was just many of those other Barnes Maze CDEs. And again, you know, many of them are sort of metadata in that they explain, you know, some of the values for the equipment of the Barnes Maze itself. And you might say, well, this seems silly to copy this over and over and over again. But like I said, what that does is it gives us a lot of information for every one of our rows. So when it comes time, if you're going to combine data, you might just be grabbing a few of these subjects, and what goes with it is all this other metadata, so you don't lose anything.
So this is kind of a question I just wanted to get other reactions to potentially. I look on the list of CDEs and I see there's certain models like fluid percussion injury or closed head injury impact. I don't see blast tube. Is that because those folks have not been using standardized procedures, or because they declined to do so, or I thought that would have been one of the common things I would have seen in this precise TBI website. So
Right.
I'm, because that's where I'm embarking. So I'm kind of wondering, does that mean I should be setting that up and working with you guys we get to write the dictionary?
Do you want to? It's coming. It's almost.
Oh, okay.
Yeah.
Great. If we should probably maybe talk to you soon so that we don't already go down the wrong avenue in about a month.
So those are done and they'll be in the next release. So there's tube, shock tube and open field. And your feedback soon.
Yeah.
When's
That's it. But
next, a week or two? Yeah,
Oh,
we
a week or
wanted to
two.
get, yeah. No, they're done. And we appreciate your feedback too. If so, feel free to give us.
I think your initial instinct was 100% correct, though. If there aren't CDEs, they're not listed on Precise, as Michelle said, contact Precise. They're either in the works, but you should have a say in them, and there are working groups that you can help with. But if there's not, then it points to a need. So I think really being proactive about this and making it a true community resource is exactly the way that you should look at it. I think we've said a couple of times, but I think it's worth repeating. The fact that it is not there doesn't mean it's not important. It just means that we haven't gotten to it yet, or that there hasn't been, sufficient expertise, enough people involved to say, these are the things that we need. But we really hope that people will start to view it that way, that these are owned by the community for community work, and you always feel free to reach out.
Already there. It's already there, but it's right now it's a curating step with a reviewer.
I just had a quick question about the kind of possible integration of protocol.io. And I may be saying that wrong. So I know that like you can set up the protocol to have all of those mechanistic, all the nitty gritty details of equipment and settings. Is there a way to link that to this, or just seeing like if you take the time to create 100 variables, say that.
I'm going to talk about tomorrow.
Okay. Yeah.
Perfect. Yeah. The spoiler alert, yes, but yes, Zong's going to give a talk about how the sort of integration of all of these great precise tools, including protocols.io. Real quick, I just wanted, this talk is about CDEs and mapping to CDEs, but I also want to make it clear, I think it's been discussed a little bit, and obviously we talked about if you have certain things that aren't already CDEs yet. But if you are maybe not quite to the step of mapping to your CDEs, I do highly suggest that you are still considering to make your data into this sort of tight, what we'd call a tidy format. So
Tidy sounds like a value judgment. Did you make this up?
Yeah, no, I'm sorry. And that's why I put it in italics. This is not a thing that we made up. It's much like data wrangling. That seems like a stupid thing Adam thought up. It's a real term. I don't mean that Adam ever thinks up stupid things. That wouldn't, of course not. No, tidy is an actual term that is used in data science to refer to a very specific type of formatting. If you want to know even more about it, Abel could tell you how some of these you can even be like semi-tidy, right? But it's a format that has a certain, and I was going to go over here like just a couple of the sort of important things about organizing in a tidy format. And I wanted to add this because I do think it's extremely important as you're going through organizing your data in the first place to consider this, just so that we avoid these sort of spreadsheets that again are interpretable by you, but definitely wouldn't be interpretable by others, and certainly not by machines. Just some very basic considerations for making your data into what's known as a tidy format in data science.
Russell, can I just jump in again? Two quick things. When I started doing this, what is the logic of me spending the time? One of the things Russell talked about already is I've had 6 different trainees through the lab create 6 different versions of an Excel file that then I created into a 7th version, which wasn't tidy either. If you can get your lab convinced to start using a tidy format, all of your trainees will now be using the same format for their Excel, and it will be the same format that you want, which saves a lot of time, and it also makes your data easier to use. The other one, Adam, so if I hand you a couple of data sets, they're in tidy format to get help with big data, because I'm in a small lab, I don't do big data. How much effort do you require if I give you like 10 files that are all tidy?
If it's in tidy format and I assign it to one of the postdocs who's a data scientist, they
Right.
will churn a Jupyter notebook back to you that has a complete machine learning analysis of everything you've ever done and all the descriptive statistics in about 5 minutes.
But what if, how much effort is it if I send you my original data?
They'll say, boss, is going to take 50% of my time. Do you have a budget for 50% of my time for 6 months?
So another real advantage for a small lab to prospectively put their data in tidy format is if you want to collaborate with data scientists or your biostatistician at your university and you hand it to them in tidy format, you save a ton of effort, which in grant dollars means a ton of money. So there's another incentive for a small lab that doesn't traditionally do bioinformatics.
That's a great point.
This is what I was saying earlier about planning versus doing.
Yeah.
It's exactly what I was trying to get at. You have your economies of scale, really saving you time and grief. And you can get it all done on a computer chip that, you know, before you know it's gonna take 5 seconds. Right now, 5 minutes, but 20 years ago, it was 5 days. So, I mean, the visualization for if you want to come with the stuff are just gonna be bonkers. No kidding, because you're gonna be able to get 3-dimensional math, maybe even make cartoons out of the stuff. And then, you know, look for local minima and maxima in these studies. I mean, I'm thinking about this stuff, but to be honest with you, you're too, you know, this, you know, so the way I think about this is, you know, you have this very high dimensional problem, right? And what you're trying to do is get a slice through this that everybody can share it and understand and harmonize them. And what you don't know are all the contours and everything between all the behavioral tests just alone that you need to just get in there and look at. And so you could be doing this, and when these AI chips come out and really are able to take all this data that you've been able to process and make a visualization of some of these, I don't know, the term used to be hyperspectral, multispectral cube. You're going to go bonkers. I mean, you guys are going to harmonize things. You're going to have real serious advances. It's going to make all the proteomics much more simpler. And, you know, again, I can take some of that money that, you know, you've been fretting over and you know, get you new students.
Yeah. So, yeah, okay. Okay, now it's bad cop time. So we have something on our application called DMAP. So data sharing aspects. So people have talked to before today was like carrots, but it's not really a stick, but would it be helpful to make this the standard format that you'd be sharing data in? So under the DMAP, if you're doing a preclinical study, your data needs to be in a tidy format.
Yeah, I mean, yeah, I mean, and this is
Add that to the NOCI, Anthony.
Yeah, no, go ahead.
Yes.
Good. I'm glad we got the
I
mic.
mean, there is no question on this. Like,
yeah,
I mean, I'll let Russell finish this, and we're gonna see this tomorrow. Some of that dream, you don't need the AI chips. We can do it right now, and we will see that tomorrow. But it really is 3 principles that Russell is gonna show that can make all of this so easy, so fast, so economically scalable, that it's so dumb that we're not doing it already.
Yeah.
So let's just.
Yeah, and it really doesn't, it's sometimes I think seems a little non-intuitive to some folks. I mean, it just depends on the way you organize your data in your lab. But if you can start thinking about it in this term, and like you said about, it's very simple. This is if you've ever uploaded anything to the ODC, you upload it in tidy format anyway. It's already that. All we're really saying as far as the tidy goes is that your columns across the top, those are your variable names, right? And you don't want to repeat variable names. Each variable should have its own name. That first row there is where the variable names live, in the first row. So we're talking about very simple things like just don't skip a row. Sometimes people, and this is like, Gene, and we all have spreadsheets like this. This is absolutely we will often organize it sort of visually so that we have it in separate little sections because it helps us see it that way. All we're asking is that when you prepare your data to be machine readable or uploaded to ODC, just remove some of those things that kind of help you, and it's going to help everybody. Taking those blank rows out. All of our rows themselves, like we just saw, those are actual observations. So obviously in that long format, you're going to have if you have a time series experiment, you're going to have the same animal or patient or whoever repeated a number of times, each one for a different time point. Yeah, that's why I just said multiple rows. And really, that's the gist of it. Yeah.
That was my question with respect to that. So in the data set, that example that you just used, where it's the same animal over multiple days, right?
Mhm.
And I probably missed this when you said this before. What is the advantage of doing the transposition so that all of those for one animal? So you've got what, 16 or 8 rows
Right.
for one animal, or 16 rows, which I can forget, I can't remember. Because for example, that's the Barnes maze, right? So let's say for that same animal, the next variable is, let's say, elevated plus maze.
Mhm.
And that's one value done on one day. It's not a time series.
Right,
So
right.
that means 15 of those rows are going to be blank before you get to the next animal.
Yeah, I mean,
Okay.
yes, we're fine with that.
Okay, no.
I mean, and this is an important thing. We often have this where there's time series and then time invariant. If it's a time invariant variable, something that is like metadata, then typically we would actually just repeat it. Now, obviously, if it's an outcome measure, let's say, your elevated maze, whatever day that's on, that gets, and it's only one time, that gets that one row. And so what you'll end up with, and we may look at this in a minute
It will be,
actually with PJ. Yeah, it's going to look a little bit like a patchwork. And
Right, right.
that's exactly right. And this is where that disconnect sometimes comes from, and where some people find this a little non-intuitive. They would look at that and go, I don't understand this, but machines love it. And if we want to do the type of things that Anthony's talking about, we need it to look like that.
Yes, vectors in here too, which is more things you make scale, or the easier your life might get.
And Ramesh, I also wanted to add that one of my first contributions here was when I first saw long format, my head exploded. I'm like, I can't visualize my data this way. There's all these animals, all these rows, blah, blah, blah. And so I went to Abel, who's sitting right behind you, and I said, Abel, this is not tenable. How do we fix this? I need tabs. So at least I can see my Barnes maze data on one tab, and I can see my elevated plus on another tab, right? If you're using the principles of tidy, right, and you save these on separate tabs, we can save them as individual CSVs. And then Abel created a tool so that, which we're going to talk about in a minute, so that you can combine things, right? So this is, different people see their data in different ways and need to visualize it in different ways. Communicating with us, the team, we can come up with ways that work so that you can visualize your data as however you intuit it, but also be able to put the data in tidy.
So I may be jumping the gun, but I'm a little dense. So is Precise going to be able, for example, if somebody wants to do a study, can they get like a template Excel file that they can download from the Precise site and just fill it in? So they don't have to worry about, is this formatted right, and go back and forth, but they can just download that template and fill it in.
When you download if you go to the CDEs and you copy them and then you paste them, all of them across, now you have your template. Right.
Sushi menu.
That's
And then
it.
you can create the column.
Yeah, and that's the tool we would like as sort of a shopping cart, but you certainly could get it. I thought was really interesting, actually looking at the two examples together, and I don't know if this is beating a dead horse, but since tidy format actually does confuse a lot of people. If you look at the left data set versus the right data set, and you look at the information content in the right data set, it is much more explicit and machine readable. So on the left, it has, this is time 1, 2, 3, 4, 5, 6. On the right, it's the exact time that was used as an integer, which means you can ask for things that happened at this time versus this time. That is not in that other data set. You'd have to read the paper. Also, if you, again, wanted to perform, well, what happens in earlier trials rather than later trials? Earlier trials is just give me everything with a number less than 5, because now 5 is, you can operate on it, whereas in the other one, you can't. You have to say, well, it's in rows and I'm going to have to get this. But it's really quite stark when you look at it here, if you think about it, that there's just a lot more information here that you can work with than there is in the other format. And I don't think that that's always apparent to people such as myself, for whom, you know, a spreadsheet is a spreadsheet.
All right. Okay, great. Thank you all. This has actually been a great, very useful discussion, I think, and thinking about precise CDEs, thinking about getting stuff into this format. And as Jean mentioned, we talked about first of all, you saw that what all I was showing here was, let's say, for instance, Barnes maze. If we went back and remember, we have these different precise CDE domains. Many times people will just create separate spreadsheets or separate tabs that then you can create into separate CSVs for each of your domains. So you may have your subject specific domains, you may have your injury model domain, you may have your outcome measures, and it sometimes can help keep you organized to keep those separated. But when it comes time to bring them all together, we have I think some cool new tools to do that. Oh, here's a summary. Why do we need to, I've already said all this a million times. You can download it. You can copy and transpaste, or you can use R, you can, or Python, whatever you like. You can insert these as long as you have animal ID and your injury lapse time in the first 2 columns. And as Marianne said, you get a lot more information out of kind of a smaller amount of columns that you're using. You can add your data in, and then finally, we can combine it all together.